take a look at example 2. Example 2 says 10 dartboard targets are being painted as shown in the following picture. The radius of the smallest circle is 3 inches, and each successive larger circle is 3 inches more in radius than the circle before it. A tester of red and white paint is purchased to paint the target. Each 8-ounce can of paint covers 16 square feet. Is there enough paint of each color to create all 10 targets? So we're going to create 10 of these targets over here. So if I fill in some of my radius here, I know the first one is 3. Then as I work out, and I'm going to show this separately, so I'm just kind of going to work around the circle here. To go out to the red circle here, this red circle has a radius of 3 more than that, which is 6. And then I want to go out to the next circle, which is the white circle out here. And this circle has a radius 3 more than 6, which is 9. And then finally going all the way out to the edge here, let's see, we could do it maybe here. This one would be 3 more than 9, which is 12. And these are all inches. Okay. Now, what you have to realize here is this is a fairly complex problem because you kind of have to picture how you're going to find each of your different targets. So let's think about how much paint I would need for the red. So we would want to look at what makes up the red parts of the target. So if you picture this circle, I can see I have this inner circle here of red. However, you can see that the white part is missing the red. So you can imagine I could find the area of this circle, but I would have to take out this white part here. And same thing with this big circle here. We would want to take out the white. Now, the white involves everything here. If I'm finding the area of this white circle, it includes everything inside of here as well. So what I'm really doing here is I would have to start with this outer circle, then I would subtract out the white, but then I'd have to add back in the red and then subtract out the white here. So let's represent that over here. We would have the area of the red would start with the area of our 12-inch circle. Then we'd subtract out the area of our 9-inch circle. Then we'll add back in the area of our 6-inch circle. And finally subtract out the area of our, area of our 3-inch circle. So you can see that we're going to want to find the areas of each one of those circles. So we should probably do that. Let's pull off to the side here and find the areas of each one. So we want to find the area of our 12, and area of a circle is pi r squared, so this is just pi times. And I want to stop here because you'll notice something, and this tends to throw people off. All of these are in inches, but look at what the paint covers, 16 square feet. So I don't want to do this in inches, I want to figure it out in feet. So the first thing I want to do is figure out how many feet 12 inches is. Well, that's 1 foot. So this would actually be a radius of 1 squared. Okay, so you got to be careful about that. Make sure that you're paying attention to your units. Okay, so let's evaluate that. We get 3.14. For area of the circle with 9 inches. Now, 9 is actually going to come out to be 9 out of 12 because you would divide it by 12 since there are 12 inches in a foot. And 9/12 reduces to 3/4. So this would be pi times 3/4 squared. And that gives us an area of 1.77. Area of the 6-inch circle. Now 6 inches is half of a foot, so this would be 1/2 squared, and that comes out to be 0.79. And then finally, area of the 3-inch circle. Now 3 inches out of 12 reduces to 1/4, so this would be pi times 1/4 squared. And that works out to be 0.2. Okay, so now that I have all of my areas, we can figure out the area of the red. So let's go ahead and do that. So we know the area of 12 is 3.14. We're going to subtract out the area of the 9-inch circle, which is 1.77 feet squared, plus the area of the 6-inch circle, which is 0.79, and then subtract out the area of the 3-inch circle, which is 0.2 feet squared. And so when we add all these together, we get 1.96 feet squared. So that's to create one target. And remember, we're not creating just one target, we're creating 10 of them. So if we take our 1.96 and we multiply times 10, because we're going to create 10 different targets, so all 10 targets. So if I'm going to multiply that by 10, I get 19.6 feet squared. And if you notice, each can of paint only covers 16 square feet. Well, we have 19, so we're not going to have enough red. So we will come to that conclusion. There is not enough red paint. However, they're asking for both red and white, so we also want to calculate the white. So let's think about how the area of the white circle, the white part of our dartboard, would be constructed. Now this one's a little bit smaller because we don't really have to take this outer circle into account because we're only looking for how much white paint we're going to use. So let's think about this one. We would start with our white circle. So the outer white circle is the actual 9-inch circle. So we're going to take the area of the 9-inch circle. We'd have to subtract out this red circle, but remember that includes this white here, so we're going to have to add that back in. So we subtract the area of this red one, which is 6 inches. And then add in this white circle here, which is our 3-inch. So area of the 3-inch. Okay, so let's fill in those areas. We know we have area of the 9-inch circle is 1.77 feet squared. Subtract 0.79 and add 0.2. And that's going to give us a final answer of 1.18 feet squared. Now again, that's just for one dartboard. We're doing 10 of them, so we want to multiply this by 10. 1.18 times 10 gives us 11.8 feet squared. So since there's 16 square feet in a can, we are going to have enough for white. There is not enough red paint, but there is enough white. So probably the most difficult aspect of this problem is thinking about how you would set up finding these, the areas of how much paint you're going to use. So you have to think about when you are finding the area, it's the entire circle. So you take out the center, you're taking out everything in here as well. So I think that's the most difficult aspect of this problem. Let's take a look at one more example. And this one is actually not that difficult. This doesn't have that many steps to it. So this one says the square in the figure has a side length of 14 inches. The radius of the quarter circle is 7 inches. So you know that this side here to here is 7 inches. So in this figure, it says it's a quarter circle. Now notice this here is a quarter circle, but there are 4 of them. So really in this figure, there's one whole circle. So if we want to estimate the area of the shaded region, it says it, if we look at this, just estimating, I'd say that this shaded region is maybe about 1/4 of this entire rectangle, and you might come up with 1/3 or something like that. But remember, it's just an estimate. So it looks about 1/4 of the square. So if I'm going to estimate the area, I would need to know the area of the square. So let's start with that. Area of a square is equal to, it would be side times side, which it's a square, so both sides are the same. So this would really be 14 times 14, or 14 squared, which gives us 196 inches squared. And now we're saying that it's roughly 1/4 of that, so we want to take 1/4 times the area of our square, 196. And so we're estimating it to be about 49 inches squared. for our shaded area. So this is the area of the shaded. Part B says, what is the exact area of the shaded region? So we want to find the exact area. So area of the shaded is equal to, now let's think about this. We would first take the area of the square and subtract out. Remember we said that each one of these is a quarter of a circle? So if I'm going to take these out of the picture, 4 quarters equals 1 whole. So we were going to find the area of 1 circle and subtract that out, and that's going to leave us with the shaded area. Now we already know the area of the square from our previous work right here is 196. We don't have to do any work there. Inches squared. We do need to find the area of the circle. So area of a circle is pi times r squared, and they already told us the radius is 7 inches. So this is going to be times 7 squared. Okay, so then we can evaluate the 7 squared as 49. Now here's the only problem is that this says, what is the exact area? What that means is they're basically saying that when they say exact, it means in terms of pi. Because pi is an exact number. If you were to put it in the calculator has to round at some point. So that's not going to be an exact answer. That's going to be a rounded answer. So when it says exact, you have to leave it in terms of pi. So my final answer here is actually going to be 196, I'm going to group these two together, minus 49 pi, and this whole thing is in inches squared. So that is my final exact answer of the shaded region. But C is going to ask us to approximate it, and instead of using our calculator to use pi, they're asking us to use 22/7, and we've seen this before. We saw this on our pi day. So 22/7 is an approximate value for pi, so we're just going to plug that in. So we can take the area is equal to 196 minus 49 times 22/7. And when I evaluate that, I get 196 minus 154, and that is equal to 42, and this is in inches squared.